Hello everyone, welcome to the world of robots. In this video, we will be discussing about ultrasonic and humidity sensors. Ultrasonic sensor. It is a device used to measure distance or detect objects by using sound waves. Let us see how it works. It operates on the principle of sending out ultrasonic sound waves, typically at 40 kHz, through a transmitter and measuring the time it takes for the waves to bounce back after hitting an object. The sensor's receiver detects the reflected waves and hence locating the distance at which an object is present. Some applications of ultrasonic sensors in real life are parking assistance and collision avoiding systems, detecting the level of liquids or solids in tank, object counting and positioning in industries. In robotics, it is used for obstacle detection and avoidance. Now let's see what HC SR04 is and its pin description. It is a popular ultrasonic sensor used for distance measurement. Here you can see the transmitter and receiver of the sensor and also its 4 pins. The VCC pin, as we have already seen, supplies power to the sensor. Trick pin is the input pin where a signal is sent to trigger the sensor. To initiate measurement, a 10 microsecond pulse is sent to the trick pin. This triggers the sensor to emit an 8-cycle ultrasonic burst at 40 kHz. Echo pin is the output pin where the sensor provides a signal back to the microcontroller. The echo pin goes high when the ultrasonic wave is sent and stays high until the reflected wave is received. Ground pin again is the common ground connection to complete the circuit. It must be connected to the ground of the microcontroller. Now let us see what a humidity sensor is. It is an electronic device used to measure and monitor the moisture content in air, often expressed as relative humidity. There are 3 types of humidity sensors: capacitive, resistive and thermal sensors. A capacitive sensor measures humidity by detecting changes in capacitance due to moisture absorption. A resistive sensor measures resistance changes caused by moisture interaction with a hygroscopic material. Hygroscopic materials are nothing but substances which absorb moisture. A thermal humidity sensor detects humidity by analyzing temperature differences between dry and humid air. Applications of humidity sensors are tracking atmospheric humidity in weather stations and climate studies, enhance the accuracy of detecting fire conditions by considering humidity alongside temperature, and preventing damage caused by humidity in sensitive equipments and data centers. Now let us see the pin description of digital, analog and SPI humidity sensors. Digital humidity sensor. These sensors usually have 4 pins but often only 3 are used. VCC, which is the power supply pin, supplies power to the sensor. Its typical operating voltage is 3.3 to 5 volt. Data pin or output pin transmits the humidity and temperature data to the microcontroller. Ground pin connects to the ground of the power source. NC, which is the 4th pin, is often left unused. Analog humidity sensors measure humidity as a variable voltage output. They have 3 pins, out of which VCC and ground pins functions we have already discussed. Now analog output gives an analog voltage proportional to the humidity level as an output. This output is fed into an ADC on a microcontroller for processing. Sensors with I2C or SPI communication protocols have 4 pins, out of which 2 are VCC and ground. Let us see what SDA and SCL pins are. SDA or serial data line is used to carry data between microcontroller and sensor. It is bidirectional, used to transmit as well as receive data. SCL or serial clock line carries clock signal which synchronizes the data transfer on SDA line or synchronizes communication between sensor and microcontroller. In this video, we have learnt about ultrasonic and humidity sensors, and that brings us to the end of the sensor segment. Keep exploring, stay curious. This is Hemavati and Aditi Das signing off. See you next time.